Greetings and welcome to the AZ800 Storage Lab. This lab will cover topics like storage spaces direct, Azure File Sync with Azure Arc-enabled servers, storage spaces, volumes, physical disk sectors, allocation units, and file shares. My name is Mark Cruz. I'm an IT technician from Eagle River, Alaska. So I'll begin the lab with a high-level overview. Then we'll take a look at the code that is used to configure the lab. Then we will execute that code and configure the lab environment. The last section of the AZ800 is a pretty beefy section on storage in Windows Server. So I've created this lab on my GitHub site that we can use to test the concepts from the curriculum. So I have 4 supporting files and some visualization diagrams. So we'll begin the high-level overview by taking a look at what a file system is. A file system is a method and data structure that an operating system uses to control how data is stored and retrieved on storage devices. It defines the rules for organizing files in a hierarchical structure, managing file names, formats, permissions, and metadata. So all Windows file systems are built around 3 storage core components. So you have your files, which is a logical unit that contains data. And then we have directories, which most people refer to as folders. So containers are used to organize files and other directories in a hierarchical structure. And then volumes is the logical partitions that hold directories and files. So a volume is typically formatted with a specific file system. So in this drawing, we have our files. The files go inside folders. Folders can have other folders or files. All of those folders and files live on a volume. So that's just a basic overview of what a file system is. So now we're going to talk about Windows Server file system types. So there's 3 main types. We have the FAT, which also includes FAT32 and EXFAT. We have NTFS, which is New Technology File System, and ReFs, which is the Resilient File System. So the FAT, or File Allocation Table file system, is the oldest and simplest supported by Windows. It tracks files using a volume level table and maintains 2 copies of the table for basic resiliency. So both tables and root directory must reside at fixed locations on the disk. So FAT is limited to a maximum volume size of 4 gigabytes, so not very big. FAT32 extends that limit up to 64 gigabytes with some Windows formatting tools. And then EXFAT, which is the Extended File Allocation Table, was designed for flash storage in modern devices. So it supports much larger volumes and files and is commonly used with USB drives, SD cards, TVs, media players, gaming consoles, that kind of thing. So it's important to note that FAT and FAT32 do not provide file system level security, so permissions, auditing, etc. So you never want to use FAT or FAT32 on production server disks because you won't have those security functions. So they are only really suitable for external removable media such as USB flash drives. So next we'll talk about NTFS. So this is the standard and most widely used file system in Windows Server environments. So it offers major improvements over FAT through advanced data structures that provide better performance, reliability, and efficient disk space usage. So the key features are strong security with ACLs, which are access control lists, auditing and granular permissions. File system journaling for better cache recovery, built-in support for compression and encrypting files. Note that compression and encryption are mutually exclusive. So it also supports for disk quotas, hard links, symbolic links. Hard links are same file with multiple names, and symbolic links is kind of like a pointer to another file. So note that NTFS is required for many Windows Server roles and features, including Active Directory Domain Services, Volume Shadow Copy Service, VSS, and the Distributed File System. NTFS is required for ADDS and many of these Windows Server roles and other features because it supports advanced security, permission auditing, and storage features that those roles depend on. Now we'll talk about the newest file system, which is the Resilient File System. ReFs is Microsoft's modern file system designed for high reliability and large-scale storage. So ReFs was first introduced by Microsoft with Windows Server 2012. So we're talking file sizes that are huge amounts of data, 1 petabyte, which is 1,000 terabytes. So those are the kind of sizes that we're talking about, is 1,000 terabytes. So the key strengths are excellent resiliency against data corruption with advanced integrity checking and online repair, support for those extremely large volumes up to 35 petabytes. It's got built-in block level deduplication, and it's optimized for virtualized workloads and large sequential input-outputs. In most cases, ReFs is the recommended file system for data volumes in Windows Server 2025. Windows Server 2025 also supports ReFs boot volumes, not available in the earlier versions. So that's pretty neat that in 2025 we can use the ReFs as a boot volume. So there are a few limitations. It does not support the file level encryption or EFS encryption. It's not suitable for removable media and lacks some features required by certain legacy applications. So that's just a quick overview of the different file systems that we can use in Windows Server, or really any Windows environment. So now we're going to move on to talking about the hard drive itself. So on the hard drive, there are sections called sectors. So a sector is the smallest physical unit of data that a storage device like a hard drive, SSD, USB flash drive can read from or write to. So there's two important types of sector size. There is the physical sector size, the real hardware size. This is the actual size of the data block written on the physical media. So since about 2011, 4 kilobytes is pretty much the default on all new HDDs and SSDs. It's a physical property of the drive. It's built into the hardware by the manufacturer. And so when we look at these examples in the picture, I've got 2 flash disks. Their physical sector size is actually 512, but then the hard disk running on the computer, its physical sector size is 4096, but it has this logical sector size for backwards compatibility. And so most modern drives still report the 512 bytes to the operating system for compatibility reasons, like 512E emulation. So even though the drive physically works in 4 kilobyte blocks, Windows traditionally talks to it in the 512 byte chunks. So what are sectors and allocation units? So we already talked about sectors. It's the smallest physical block that the disk can read and write to. So the cluster is what an allocation unit is also referred to as a cluster. And this is the smallest amount of disk space a file can occupy. So file systems don't store files byte to byte. They store files in chunks called clusters. Even a tiny file, 1 byte, will take up at least 1 full cluster. So if you have a 4 kilobyte cluster and somehow just had a file that was 1 byte, it would take up the entire 4 kilobit cluster. So why cluster size? Why does it matter? So again, the cluster size represents the smallest amount of disk space that can be allocated to the file. So if a file is smaller than the cluster size, the remaining space in that cluster becomes slack space. It becomes wasted. So larger cluster sizes tend to waste more space when you have many small files. Smaller cluster sizes reduce waste but increase overhead on the reading or the writing of files, may require more disk operations and metadata management. So the best practice is to match your allocation unit size as closely as possible to the typical file or record size used by your workplace. So in this example here where it says why cluster size matters, we've got our 8 kilobyte database record. That's the common record size. So what we would want to do is use 8 kilobyte clusters in that scenario. And so the modern reality in 2026 is virtually all new hard disks and most solid state drives use the 4 kilobyte physical sector as the standard. Many drives still emulate the 512 byte logical sector, which we see down here in the diagram, and that's for backwards compatibility. So when you format a volume with a file system, the operating system groups these physical sectors into larger logical units called clusters, and that's what's known as the allocation unit. So kind of the key concept is formatting a volume with a file system combines physical sectors into logical clusters, also referred to as allocation units. For example, with the now standard 4 kilobyte sector, a 4 kilobyte cluster uses 1 physical sector. A 16 uses 4, and a 64 kilobyte cluster uses 16 physical sectors. So that's what we see here in the center. So this is the physical sectors, the logical grouping, the allocation units, and just a brief example of why the allocation size matters when it comes to file size. So now that we've talked about file systems, we'll move into talking about storage spaces and storage spaces direct. Storage spaces is Microsoft's software-defined storage feature introduced in Windows Server 2012. It allows you to create virtual disks, which is known as storage spaces, from groups of physical disks, similar to a software RAID solution. It's designed primarily for a single server deployment and is available in Windows Server Standard and Data Center editions. So the key features are storage pools, so groups of physical disks, SATA, SAS, NVMe, USB, etc., that act as a single pool of storage capacity. Next, we'll talk about a virtual disk. So you can create resilient virtual disks from that pool with different resiliency types. So simple, mirror, parity. And then we can also configure thin provisioning or fixed. The thin provisioning, it means you can create virtual disks larger than the current physical capacity and then grow them later. And then you can also do tiering, where you can combine your SSDs and the slower HDDs in the same pool for automatic hot-cold data tiering. And then you can also configure a hot spare. So how it works is you create a storage pool from the available disks. From that pool, you create one or more virtual disks with your chosen resiliency and provisioning type. Then you format that virtual disk with a file system, NTFS or ReFs, and then those virtual disks appear as normal drives in Windows. So there are some limitations to this technology. Single server only, no high availability across multiple servers, no automatic failover, limited scalability compared to storage spaces direct. One thing to note, it does not use SMB 3.0 for the internal storage traffic, SMB is only used if you share the volumes over a network. So the typical use cases have been simple, cost-effective storage on a single server, home labs and small business environments replicating traditional hardware RAID cards, backing up targets or archive storage, and development and test environments. So as we add drives to the server, that's referred to as vertical scaling. So we have one server and we're adding memory or we're adding hard disks. That is referred to as vertical scaling. Horizontal scaling refers to adding a computer into a cluster. So not only are you getting more storage, you're also getting more CPU, more memory. You're getting an entire set of resources added in. And so that is referred to as horizontal scaling. So we'll just give an overview of the vertical scaling. So we already talked about adding more CPU or more RAM or storage to the existing server. So we're making one server more powerful. That's kind of the key. So in this example, we have a server. It's got 32 CPUs and 128 gigabytes of RAM. So effectively, they are the same as 4 servers with 8 CPUs and 32 gigabytes of RAM because they're all working together. So even though there are pluses and minuses to both, but the key thing to remember is effectively in this example, they have the same power. But we'll talk about how they're not exactly equal, but in terms of raw compute power, they are equivalent. So when looking at the vertical scaling, it's simple to implement, no load balancing required, easier to manage. It's good for databases, legacy applications. Applications typically require little or no redesign. So the drawbacks are hardware limits are eventually reached. Right? With the cluster scenario, we can just keep adding as many servers as we want to the cluster. But on an individual server, we will reach a point where we cannot add another hard drive. There just won't simply be enough ports on the motherboard. We won't be able to add any more memory sticks. And servers that can handle high amounts of memory and disk are often more expensive. So it actually might even be a little bit more cost effective to use the horizontal scaling method, because to reach the kind of capacity that you might need, the single server might not even be able to hold 128 gigabytes of RAM. Maybe you need 256, maybe you need 512. And it's much harder or much more expensive to find a server that can have those higher resource limits than simply having the cluster and adding the resources you need them. So some example use cases for the vertical scaling: database workloads, memory intensive workloads, stuff like that. So now we'll talk about horizontal scaling. We kind of already talked about how effectively, in terms of raw power, these are equivalent, but they are not equal. So the benefit of the cluster is we have increased capacity simply by adding the servers. There's better fault tolerance, higher availability, easier incremental growth, supports a large number of users. Maintenance can be performed with little downtime, and it's usually a bit more cost effective at a large scale. In the small lab environment, it makes sense to just kind of set up the vertical scaling. But when we start talking about production environments, and we need the environment to grow, there's a lot of advantages to the horizontal scaling. So I've got this little chart here we'll go over real quick. So vertical scaling, add CPU, RAM to the one server. Horizontal scaling, add more servers. Simple architecture versus the more complex architecture. Limited by hardware maximums, right, in vertical scaling. Using a single server versus multiple. Better for databases, better for web apps. The horizontal scaling can be a bit more expensive. The vertical scaling is if you're pushing it to the resource limits. And then there's better resiliency in the horizontal scaling. So an easy way to remember this: vertical scaling, bigger, powerful server to hit those limits. Horizontal scaling just means more servers. So failover clustering, higher availability, no additional CPU RAM capacity. So horizontal scaling is often considered more cost-effective because you can grow incrementally using commodity hardware, while vertical scaling usually requires increasingly expensive high-end hardware. So the reason horizontal scaling is more cost-effective is, again, you can scale gradually. You can use cheaper hardware. So several standard servers are often less expensive than one gigantic high-performance server. You avoid large upfront investment. You can add additional servers as you need them. And there's just better availability. If there's a problem with the server, you can take it down, replace it without losing service. So that's just a quick breakdown of kind of what we mean when we say vertical and horizontal scaling. Now that we've covered a lot of the basics, we do have to cover another core concept, and that is SMB, which is Server Message Block. So what is SMB? So it's a widely used network file sharing protocol that allows computers to share files, printers, and other resources over the network. So it's TCP, IP, and it enables applications or users on one computer to access files, folders, and services located on a remote server as if they were local. Some of the key capabilities, right, is read, write, create, modify, and delete files and folders on remote servers, access shared printers and other network resources, support for secure authentication and granular permissions, and provide high performance, reliable file access over local area networks, and sometimes even WANs. So SMB is the standard protocol used by Windows clients and servers for file sharing. It's evolved significantly over time, with major improvements made in SMB 3.0, which was introduced in Windows Server 2012. So this includes better performance, security, features like SMB Direct, which is RDMA, and SMB Multi-Channel. So RDMA, which is Remote Direct Memory Access, lets one computer transfer data directly into another computer's memory without involving the CPU. So the benefit to that is very low latency, high throughput, and lower CPU usage. So RDMA allows the servers to transfer the data directly. And then SMB multi-channel, it's used, or SMB multi-channel allows SMB file sharing to use multiple network connections simultaneously between the two computers. So the benefits are increased bandwidth because it's combining multiple NICs, automatic load balancing, and fault tolerance if one of the network paths go down. So those are some of the features that were introduced in SMB 3.0. So now that we've covered storage spaces and SMB, we can talk about storage spaces direct. So what is storage spaces direct? Storage Spaces Direct is Microsoft's hyper-converged software-defined storage solution. It allows you to pool together local disks from multiple servers and create a highly available, scalable, shared storage system without needing a traditional SAN, which is a storage area network. So this was introduced in Windows Server 2016, and it's a major evolution from the original normal storage spaces, which we already talked about. So we'll kind of talk about how it works. So instead of using expensive shared storage hardware, like the SAN, Storage Spaces Direct turns the local disks inside each clustered node into a unified, resilient storage pool. So the core concepts are each server contributes its own local disks. So SATA, SAS, NVMe. and then it aggregates all these disks across the cluster into one big storage pool. So we have 4 servers, all their disks, they all get combined into one big storage pool. It then creates virtual disks that are distributed across all the servers. So some of the key features of Storage Spaces Direct are high availability. The data remains accessible even if a server or disk fails. Scalability supports 2 to 16 servers per cluster. Hyper-converged, you can use the Hyper-V and storage to run on the same servers. You could also set it up disaggregated, where storage cluster is separate from compute. Uses SMB 3.0 and offers tiering. So it can automatically tier between SSDs and HDDs. And then deduplication, compression, and encryption are supported. So why is SMB 3.0 required for Storage Spaces Direct? Storage Spaces Direct uses SMB 3 as its software storage bus. So this is how the servers in the cluster talk to each other for storage traffic. So why is failover clustering required when we talk about Storage Spaces Direct? And we'll just kind of talk about what failover clustering is. So in Windows, servers can have a role to be a failover cluster. Failover clustering is a high availability feature in Windows Server that allows multiple servers, referred to as nodes, to work together in a single system. If one node fails, another node automatically takes over the workload with minimal or no downtime. It's one of the most important technologies for building resilient, mission-critical environments. So the reasons we would use failover clustering already mentioned: high availability, automatic failover, scalability, simplified management, and support for key workloads like Hyper-V, SQL, file servers, and Storage Spaces Direct. So now we'll kind of talk about how it works. So cluster nodes. So 2 or more physical or virtual servers, and all of the nodes must be joined to the same Active Directory domain. They'll all have a clustered shared volume, which are special volumes that allow nodes to access the same storage simultaneously. Networks. So management production network for client access, heartbeat cluster network for internal cluster communication, and then you could also have a live migration network in Hyper-V clusters. And then another interesting concept is quorum. So quorum is a voting mechanism that helps clusters decide which nodes are healthy and prevents split brain scenarios. So you can have a disk witness, that counts as a vote, a file share witness, that counts as a vote, or a cloud witness, and that counts as a vote. And then the server also counts as a vote. And so depending if you've got 5, 6, 7 clusters, it'll add up all the votes and then help to determine which nodes are healthy. So this is just a basic overview showing that when the nodes are operating in a cluster, if one fails, operations continue through the other nodes in the cluster. Now we'll move on to our next topic, which is Azure File Sync. So when we mention Azure File Sync, what we're talking about is a hybrid file server infrastructure. And so when we talk about this solution, the best place to start is talking about Azure Files and what it is. So Azure Files is a fully managed serverless file storage service in Microsoft Azure that provides the familiar experience of a traditional on-premise file share. So you can kind of think of like it as a file share in the cloud. So the key capabilities, no virtual machines, no operating systems, no patching. Microsoft handles all of that. It's massive at scale. We're talking 100 TB of data. It's secure by default. You can access it anywhere, cross-platform support, enterprise-grade identity and permissions, snapshot backups, and high availability. So Azure Files is ideal for lifting and shifting on-premise file servers to the cloud. And this allows us to build the cloud-native applications and enable hybrid scenarios. So now we'll talk about Azure File Sync, which is a storage sync service. So we just talked about the Azure Files, which is like a file share in the cloud. Now we're talking about Azure File Sync. So this is a hybrid cloud service that lets you centralize your organization's file shares in Azure Files while maintaining the performance, compatibility, and flexibility of the traditional on-premise file server. So what that means is we're going to be able to take an on-premise server and sync it to our file share in Azure. So some of the benefits of Azure File Sync, you can have multi-site sync, cloud tiering, cloud backup, and disaster recovery. So the idea is we will register our servers to a sync group. We'll put that sync group in a cloud endpoint, attach the file share to the cloud endpoint, and then we will have our on-premise file share syncing with our Azure file share. So this is just a simple diagram explaining that we'll have these servers that have these file shares, and they'll be shared out. Like, for example, this one is D dev, and then we're going to sync this all the way up into Azure. When we do the Azure File Sync Lab, we'll have to onboard our servers into Azure Arc. So one of the benefits of having your servers in Arc is they can be managed by role-based access control. So real quick, we'll just give an overview of what Azure RBAC is. So Azure RBAC controls who can do what on which Azure resources. So a role assignment is made up of 3 components: a security principal, who, a role definition, what they can do, and a scope, which is where. So examples of security principals are a user, like John Doe, a group, like dev, a service principal, like an application used for automation, or a managed identity, like an Azure VM identity. Then we move on to the role, so a collection of permissions that define the allowed actions. So the owner has full access, including assigning roles. The contributor can manage resources, but cannot assign those roles. Reader is view only, and then user access administrator can manage access permissions. And then finally, the scope where. So can you do this in the management group level, the subscription level, the resource level, or the actual resource itself? So an example, if you assign reader at the subscription level, the user can read all resources, groups, and resources in the subscription. So if we apply it right here, they also get the same here. So just another example of how it works. So we need to talk about who is making the request, the security principal, what role do they have, the role definition, and at what scope was the role assigned. Okay, and then the last topic we'll talk about at a high level is Azure Arc. So this is a set of technologies that brings Azure security, governance, and cloud-native services to a hybrid multi-cloud and edge environment. So it gives organizations a centralized, unified way to manage securely and monitor their distributed infrastructure. So Azure Arc supports Linux servers, Kubernetes clusters, SQL Server, or other Azure data services. So Azure Arc extends the cloud native services across your entire estate. It also lets you run Azure data services and Azure machine learning on containerized infrastructure anywhere. So the idea is you have this Azure control plane, right? So the Azure control plane manages the life cycle of the resources, so like provisioning, scaling, stopping, and deleting. It includes the Azure Fabric Controller and the Azure Resource Manager known as ARM. So those provide a consistent management layer for creating, updating, and deleting the resources. So that's a key concept from the curriculum is this Azure Resource Manager. So what this means is when we add our Windows or Linux server or Kubernetes cluster to Azure Arc, at that point it becomes an object in Azure, and then we can apply RBAC rules, for example. So the idea is we're taking something like a Linux server or Windows server that is not manageable in Azure, but then we onboard it in Arc so that we can start applying Azure technologies to the Arc-enabled servers. So this will conclude the high-level overview of the lab. So now we'll jump into the code and take a look at the code that we'll use to configure the lab. The first part of the lab is just a demonstration on how to configure volumes and work with partitions on removable media. And then we'll also just take a look at some of the nuances involved with how a computer views a gigabyte. And just for a quick example, so I've got this equation plugged in here, 1 gigabyte. So it's common knowledge there's 1,000 megabytes in a gigabyte. But is that true? And so in this first example, what we'll see is it's actually more like 1,024 megabytes in a gigabyte. And even that is actually not 100% accurate. So when we just plug in 1 gigabyte, we don't get a 1 or like an even 1 all zeros. We get 107, which just doesn't seem to make sense. But it comes from the calculation of 1,024 times 1,024 times 1,024. So now we can see that the numbers are identical. So depending on, we'll use certain PowerShell commands where we can simply type in 1 GB, but if you were to use bytes, you would actually have to use this value. So that's just a concept in computers of how what actually is the size of a gigabyte. And then I've got some simple examples that we'll do that just show the different calculations of how the computer views gigabytes, terabytes. So then we'll take a look at the sector sizes. We use the FSU till. Doesn't work that well. I found it was better just to use PowerShell and use get physical disk. And then we'll do different tests. We'll format different file systems, do different allocation unit size. This is the cluster size up on the disk. And then we'll remove the partitions and then set up 2 different file systems on 1 removable media source. So it'll just be a quick demonstration of how we format volumes and just work with these partitions and the file systems. So then we'll move into the vertical scaling lab, and this will use storage spaces as the demonstration technology. So we'll create this virtual machine with 4 non-OS disks that are 250 gigabytes, and then we will initialize those disks and turn them into drives. And then we're going to add more disks to the server, and that is the vertical scaling portion. So we've got we've got a server. It's got 5 disks on it, or excuse me, 4 non-OS disks. And then we're going to add 18 more disks to the server that we'll be doing the vertical scaling demonstration on. And then we'll initialize all of those disks. So we'll turn them all into drives. And then we will format them and then turn them into file shares. And then at that point, we'll take a look at the allocation size of the file systems. Then we'll come in and we'll remove all of those shares, and we'll start back from 0 so that all of the disks are in an offline raw state. And then we will create a storage pool with PowerShell and then a new virtual disk from that storage pool, and then format the volume and share it. And then we'll reset everything one more time, and then we'll do it with the graphical user interface. So first we'll set up storage spaces with PowerShell, and then we'll set it up with the graphical user interface. The next section of the lab is an example of horizontal scaling. And so we'll do this with a storage spaces direct failover cluster. So in order to have a failover cluster, all of the servers participating in the cluster must be part of the same domain. So the first step will be to create a server to be the domain controller. We'll install the Active Directory Domain Services role and then promote it to be a domain controller. Next, we'll create our privileged access workstation. This is where we will configure the lab from. It will also be domain joined, and then we'll create the first 3 of our cluster nodes. At the end of the lab, we'll create a 4th one and then add it to the cluster. It's nothing too fancy here. We just rename the computer and join it to the domain. This firewall rule just allows the servers to respond to ping, which can be useful during testing. So once the servers are all part of the same domain, we can leverage the invoke command to apply commands to multiple servers at the same time. This was a key concept from the curriculum. It has to deal with WinRM, but essentially we're just using one command to run the same command on 3 different servers. So we'll leverage this invoke command from our privileged access workstation. And then we'll just check that the features were installed. So the privileged access workstation will have the PowerShell module for the failover clustering. So we actually don't have to use the invoke command. We can run the new cluster command directly on the privileged access workstation. Even though it's not going to be participating in the cluster, it has the PowerShell libraries or files on it. So then we'll just confirm that the cluster was made. And then an interesting note is once you make the cluster, it becomes an object in Active Directory. It becomes a computer object. Later, when we enable the scale out file server role, that also will become an Active Directory object. So at this point, with the cluster set up, we're ready to enable storage spaces direct. We just have to connect to one of the servers in the cluster to enable storage spaces direct, and then on all of the servers, it will configure them with storage spaces direct. And then we'll just check each server to make sure that it's configured. One thing that we'll note is in the C drive, we now have the cluster storage volume. So if we create a file in that on the C drive on any of the servers, it gets replicated to the other servers. Then we'll just take a look at the disk sizes, and then we'll create our first storage pool in storage spaces direct. So what we're doing is we've created this cluster. Now they have all of their disks. Now we're aggregating all of the disks from each server into a storage pool. And at that point, we're ready to start doing something with it. So we're going to create cluster shared volumes, and we're going to be using the ReFs cluster share volume for the file system. Then we'll just confirm that everything looks good. And then we're ready to enable the scale out file server role. So we'll be looking in the graphical user interface as everything is coming up. And then we'll see the role also come online after we enter this command. Then at that point, we'll create some shares to be used in the scale out file server, and we'll share those out. And then at that point, we could start testing high availability. So stopping one of the servers and then observing that the storage is still accessible, and even updatable. And then the server comes back online, we'll take another server off just to demonstrate the high availability. So then at this point, we're going to create a fourth node and then actually begin the horizontal scaling. So we're going to create this fourth node. It's going to have a bit bigger disks. And then by adding that node to the cluster, we will begin horizontal scaling. So we have to add it to the domain, make sure the services are on there, and then we will add the cluster or the node to the cluster. And then we'll just run some checks to make sure everything looks okay. And there is a key command where we need to redistribute the pool slab so that performance and capacity are evenly utilized after adding the node. So we add that fourth one in, and we kind of have to redistribute the storage. And then that will conclude the scale out file server role. And this is just a nice little drawing explaining the setup. So the last technology we'll look at is the hybrid file infrastructure, which is Azure Files combined with Azure File Sync. So a lot of the configuration can be done in the Azure portal with the GUI, but I have scripted it all out so that we can do this in the Cloud Shell. So initially I just define some variables that we'll use in the AZ command. So first I just create the group. We need to create the storage account. That's where we access the Azure files. We need to assign a role to the Microsoft Storage Sync service before moving on to the actual role assignment in the scope there. Then we're going to use the Cloud Shell to create and configure the file share. So right here, we'll set the quota, we'll make it transaction optimized, and then we'll take a look at those settings. And then once we see that the file share has been created with those settings, we will slightly alter it by changing the access tier to hot and increasing the quota to 1,000. So there is an extension we need. We need this storage sync command. So you have to load the extension into your Cloud Shell. And then we can start working with storage sync. And then we'll actually create the storage sync object, create the sync group, and then add all of the resources that we need into the sync group. So we'll be able to use our PAW from the previous demonstration, but we'll have our privileged access workstation that we'll be using. Then we'll create the servers that will participate in the storage sync service in Azure File Sync. And in this instance, we're going to add them all to the same domain so that we can leverage the invoke command. So then we'll just kind of check on the status of the disks, and then we'll format all of those disks and assign the letter. Then we'll create some file shares. So at that point, we're ready to onboard the file servers into Azure Arc. The way this was done was with Azure Key Vault, but that is changing. And now in Azure File Sync, they want your file servers to be Azure Arc enabled when possible. So the first thing we're going to do is get all of these machines connected to Azure Arc. At that point, we will install the storage sync service. I made this an if-else block so that it will pull the correct MSI depending on what version of server you're running. So in the lab, it will identify we're on server 2025 and pull that MSI file for server 2025. Then we'll just check that the services are running, and then we will register the server to the storage sync service. Or excuse me, that's the next step here. So we need this storage sync service command, and then we will add the endpoints. And then at that point, we will have our Azure File Sync created. So it's a bit hard to follow here in the code, but when we do the demonstration, it'll make more sense. So essentially, we create the storage sync service, create sync groups within that service. Then we can group the file shares to their particular physical file share. So the Azure file share to the physical share. And the idea is when we create a file on the file server in our on-premise Active Directory services environment, it will sync up into the cloud. So that will conclude the high-level overview and the look at the code. So we're now ready to begin configuring the lab. So we'll begin with the demonstration of configuring volumes on removable media. This lab will have a straightforward setup. To test some of the storage concepts for the AZ800 curriculum, we don't necessarily need a big fancy lab environment. For this demonstration, we'll be using a Windows 11 machine. First, we're going to take a look at the physical and logical sector sizes on 2 USB sticks plus the laptop's hard drive. So what I have here is 2 USB sticks. So they are promotional products. First, we'll talk about this blue one. It's 8 gigabyte FAT32 file system. So on the end of it here is this cap. You pull the cap back, and then it has these pins that connect the USB to the computer. So the red one is more of a regular USB, and it doesn't even have 150 megabytes on it, and it has the FAT file system on it. So the point is that to do these storage labs, you don't need fancy equipment. You can pretty much use any removable media. So the E drive, that will be the blue 8 gigabyte USB stick. It has some files on it. Throughout the lab, we'll be reformatting partitions, reformatting the volumes, removing the partitions, so this data will get destroyed. And that is one of the concepts in the curriculum. When you start doing the kinds of things we'll be doing in this lab, your data does get destroyed. So this data will no longer be here at the end of the lab. And then the D drive is our FAT file system, and it's not even 150 megabytes. So we'll take a look at how these things are currently set up. It's important when we do stuff with disks, we have to be the administrator. So I'm going to launch PowerShell as an administrator. And so I've designed this bit of code to output a nice table with information about the hard drives. I'm going to grab this other bit while we're waiting. And so what we're going to see is the drive letter, the file system type, its size, and then its cluster size. So for example, the D drive, it's formatted with the FAT file system, not even 150 megabytes, 2 kilobyte cluster size, which I thought was odd. So the C drive, which is the laptop hard drive, you can see it's the 4 kilobyte cluster size. And our FAT32 USB stick, the 8 gigabyte one, has the 4 kilobyte cluster size. And so here we can see the friendly name, just USB flash disk, general flash disk, the logical sector sizes and the physical sector sizes, and then just the size in GB. So one thing to note is the actual physical sector size on the removable media is 512 bytes, where the physical sector size on the laptop is 4 kilobytes, or 4096 bytes. And so the reason that it has a different logical sector size is for backwards compatibility. And now quickly we'll just take a look at how PowerShell interprets kilobyte, megabyte, terabyte, all these different byte values. So if you just type 1 KB into PowerShell, it will not output 1000. Okay, it's not 1000 bits. You would think 1 kilobits. I mean, logically, you would just think there's 1000, but it's 1024. So if we want to figure out how many bytes are in a gigabyte, we multiply 1024 by 1024 by 1024. And so this is the actual number of bytes in a gigabyte. So the perception at first can be when you're first starting out with computers is that these should all be zeros. But when you start doing the math, you find out that it's not even. And so when we type in 1 gigabyte, the computer interprets it as this many bytes. So not as important with kilobyte, megabyte, but gets more important when we start talking about terabyte and petabyte. So we'll just do some examples. So if we do 1 gigabyte divided by 1000 megabytes, we get the 1.024 value. So the next kind of calculation we can do, we'll do 1024 terabytes divided by 1 petabyte to give us the integer 1. So that's just a demonstration of how the computer is interpreting gigabyte, kilobyte, and it's important for some commands that we'll enter later. We can just use the shorthand of 1 gigabyte instead of having to remember this value and type it in. And then quickly, all of those values, they are 64-bit integers. So if you want to start using them in your scripts, you just have to be cognizant of the fact that it is an integer. So if you try to do stuff like with the write verbose, you'll need to code it knowing that it is an integer. And so here I've just used the write verbose to output this nice little message about the calculation that we just did. And so it's okay to use the object like I did here in this string, and then it will output the value. And then just to recap, we talked about this during the overview. So I've got this chart here about sector size and cluster size. So just a brief recap. The smallest unit the disk hardware reads and writes is a sector, and the smallest unit the file system allocates is a cluster. So if by some miracle we had a 1 byte file, an unbelievably tiny file, and its size was 1 byte, when the file system saves it, it's going to allocate 4 kilobytes to save that 1 byte. So we've essentially lost 4,095 bytes. So to balloon that up, just so that the concept is less, that example's a bit abstract. If we have a 2 kilobyte file with the 4 kilobyte cluster size, when we save that file, the file system will allocate those 4 kilobytes to that 2 kilobyte file, and 2 kilobytes will be wasted in that cluster. And then we have the Goldilocks example. If your file, if by some miracle it was exactly 4 kilobytes, then that would match the cluster size, and there would be 0 kilobytes of wasted space. And then these are just different examples of how, when you split that cluster value for the allocation size, then you start wasting space. And so the idea is you try to figure out what is the common file size on my system and what allocation size makes sense. So since about 2011 on, especially now here in the year 2026, most of the hardware that you're going to be interacting with will have the 4 kilobyte cluster size. So now that we've kind of gone over some of those basic concepts, we'll jump in and start configuring these things. So the fsutil command will only work with the NTFS file system. So when we try to run this, we see that we are not allowed to run this command because they are formatted with the FAT file system. So we're going to go ahead and jump in. So one important thing is you have to be the administrator. And then we're going to format the drive to be NTFS with a 1 kilobyte cluster size. So now we can see that we've changed the D drive to NTFS. This was the small one. It had a 2 kilobyte cluster size and was fat. And now it has the 1 kilobyte cluster size. So these are just different examples that we could run. So for example, we'll change it back to the fat file system with the 2 kilobyte cluster. Excellent. So now we'll do the same process with the other one. We'll try the 256 kilobyte cluster. We need to change it to the E drive. And now we can see we have the 256 kilobyte cluster size. And then important to note, all of the data that we had has now been nuked. So you can see how dangerous it can be when you start playing around with partitions and formatting volumes. So to finish this off, we're going to do a demonstration where we'll take the 8 gigabyte removable media stick and we're going to partition we're going to take it and create 2 partitions and then have 2 separate file systems in each partition. So first we just need to get some information about the disks. Just triple check the disk number. And we want to be on disk 2. So we're going to get the partition that's currently on disk 2 and we're going to remove it. And now I'm opening up computer management and we'll take a look at how, with the graphical user interface, how the computer is logically looking at the drive. So going here to disk management. And there is our FAT. And here is disk 2. So we remove the partition and we can see there's no partition. So now we're going to create a new 4 gigabyte partition. And this is also a misconception. This is when the drive letter is assigned, is before the volume is actually formatted. So now we're going to create just a 4 gigabyte partition. We'll immediately get an error that it's not formatted, and if we want to format it, you could, but for the example, we will keep it unformatted for now. And mainly so we can take a look at it in computer management. So now we can see we have partitioned off part of the hard drive, and we will use that partition to create a file system. So now we'll take the rest of the partition and format it. And that's what this use maximum size parameter does. It's just the rest of the partition now will get formatted. So before we specified, hey, we want it to be 4 gigabyte. Now we're just saying use whatever you can find. And so now we have 2 partitions and they're each assigned a drive letter. And now we can use the format volume command and we'll format one of the volumes to be NTFS, and that's going to be the E volume. So change this real quick. And this will just depend on what USB devices you have plugged in at the time. So the first one will make that NTFS, and we'll do the 4 kilobyte. And then the other one will be FAT32 2048, which is 2 kilobyte. And so this is a neat little trick. So you can take one USB drive and then create two drives. So the D drive is our little red one, and now the blue one is E and F. create some files in them. Oh, this must have not kicked off yet. So that PowerShell command had just not executed yet. There we go. So the F drive is FAT32 and the E drive is NTFS. So we'll right click, go to properties. And we can see we don't have a security tab. And so that is also one of the fundamental concepts from the curriculum is NTFS gives you the ability to apply ACLs to the file. And so you can see all we have is general digital signatures. So now we'll take a look at the NTFS partition. And now we have the security tab. So that is one of the major points in between the two file systems, is that here we are allowed to assign permission, use access control lists. FAT32 does not. It's simple file sharing. So as I mentioned before, to get started with a lot of these concepts that you're going to be quizzed on, you don't need to start this huge fancy lab environment to start testing the concepts that you'll need to pass the exam. So we're now ready to jump into the vertical scaling lab. So I'm going to connect into the Hyper-V host and we'll begin the vertical scaling lab. We'll take a look at the resources on the Hyper-V host. So this is a Dell XPS 9520. It's running Windows 11. So it has 16 gigabytes of memory, two 8 gigabyte sticks, Intel Core i7 for the processor, and 20 logical processors. I've also set up a Hyper-V router to do the internet connection for my servers, but you can just use a external Hyper-V switch. We'll just be creating one virtual machine, and then we will do the scaling example on that virtual machine. So on my GitHub repository, I have several functions that allow me to create virtual machines quickly. So the link is in the description. I'm going to use these functions to create virtual machines on the Hyper-V host here. So you can just use Hyper-V Manager and create them from ISOs. I'll be using my custom functions along with a golden image of both Desktop Experience Server 2025 and Server Core 2025. So my custom function is new-lab_VM. We'll create the virtual machine, attach it to the Hyper-V switch. And in this case, it's also going to build 4 non-OS disks to the virtual machine at 250 gigabytes a piece, and then the virtual machine will be set at 2 gigabytes of memory. And so the code for all of this is available on my GitHub site. And the code to also create the golden images and how to use them is also on my GitHub site. But like I mentioned, you can just use Hyper-V Manager. We're just creating the virtual machines, and this is a nice way in the instruction set to keep track of everything. So we've got our custom functions loaded, and now we're going to create our virtual machine. And as it creates, we can monitor the process here in Hyper-V Manager. Also, at the end of this command, we'll get some nice verbose output about the process. So we're going to take a look at the disks. So my function, it created this virtual machine. This is the hard drive, and then it attached these 4 disks to the hard drive. So you could have done that all manually with the GUI, but this way when it's scripted out, it's much faster to just execute the one command and then have your lab stood up, your part of your lab environment stood up. So we will connect into the virtual machine, and the first thing we're going to do is just rename the computer. So some unique things about my golden image is I've abbreviated the out-of-box experience. So instead of having a bunch of menus to click through, we just get this first prompt, and then we go right to programming in the administrator password. So my golden image has some standard accounts that are created, Megaman and Rush. So Megaman is the administrator account, local administrator, and Rush is just a standard account. And then there's also a custom background image. So every time you create a virtual machine, it will have this background image of the AZ800 lab moose. So here we are on the virtual machine. I'm going to rename the computer. So I didn't get my enhanced session, so I just closed the session there. The enhanced session will allow us to do stuff like copy and paste. So that's a feature we'll need here. So we'll do this from an administrative prompt. And so now storage spaces is built into the operating system. And so we can use some PowerShell commands to figure out what disks would be available for a storage pool. So we'll use this git storage subsystem command to figure out which disks are available. And here we can see those 250 gigabyte disks are now available for a storage pool. So I'll grab this bit of code. So now we've created this function that will initialize the disk and then format the volume. And so when we look in File Explorer, we'll start to see our drives pop up. So we had these 250 gigabyte drives, 4 of them attached, but they were not formatted. They didn't have partitions, and now they are formatted in the NTFS file system, and we could start using them. So there's different ways that you can test the access. So for example, so this $E is a share. And so since all of the shares have been created, we can see they have these hidden shares. So right now, if we go and look, we can see that there aren't any shares, but the $administrator shares are available on each of them. So then we can test the path to that location. And we can see the paths are valid. This next function will add disks to the virtual machine. And what we're going to do is we're going to add 18 350 gigabyte disks. So if you try to do this with the graphical user interface, you can. It just takes a bit longer. But you can see the value of when you start scripting. So in this particular example, we're just creating a function. And then once we've defined the function, we can start messing around with disk count and disk size. In this example, we'll be using the disk count of 18. So we're leveraging the new -vhd command, creating the .vhdx file in the proper location, and then using these for each loops to iterate through the number of disks that you provide in the parameter set. So we give it a name, the number of disks that we want, and the size of those disks. And the reason these values exist here is as if you ran this command without these parameters here, it would just run with those default values of a disk count of 1 and 128. But we're going to specify 18 and then attach the 350 gigabyte disks. So we'll run this from the host. So now we have the function loaded into the Hyper-V host, and now we're going to execute it. And before we do, we'll get to the different file path locations, and we'll observe the disks being created. And then also logically, in computer management, we'll see the raw offline disks start to appear here as well. So you can see we have all of these, because there's 18 of them, and we can see they're just popping in. And then here on the Hyper-V host, these are all of the disks that are being created. So the initial ones, they have this different naming convention, and then the added disks have this expand and then the name of the disk. And so here are 18 disks on the Hyper-V, on the Hyper-V host, where they're located. And this is inside the guest operating system, where those disks are being presented logically, and we can begin formatting them and partitioning them. So before we jump into storage spaces, we'll just initialize all of them. And so this is another example of how just a small bit of code, the initialize raw offline disk, is just this small little for each loop, but we'll use it to format all of these and present drives to the operating system. So as this runs, we'll start to see more drives pop up here in File Explorer. And so again, you could use the graphical user interface to just take a bit more time, but it is kind of fun, and it's saves you a bit of time by being able to script it. And then we can see in computer management that they are going from raw offline to online, and then being assigned the drive letters. So now that we have all of these amazing drives, let's do something with them. So we're just going to create basic file shares on each of them. And so what's going on our single server, we have all of these disks, but right now they are not being shared. They're just only logical to the user that's logged in. So the idea is we want it to be a file server. So now we're going to start sharing out file shares from the different drives. So you can also do this from the graphical user interface, but we'll be using PowerShell. So we'll run this bit of code, and now it will create a folder called share1 in each drive and then share it out. And it's actually already done running. You can see how efficient it is. And now here are all of the shares. And inside each folder, we can begin adding files. And so when we look at it logically from the E drive, they all have a folder called share01, and this is what is presented to the user. So we're not actually sharing out the drive itself. We're creating this folder inside of the drive and then sharing it out. And then with the graphical user interface, you would just create the user, go to properties, and then sharing, advanced sharing, and then here you can modify your permissions and begin the file share. But since we use PowerShell, we instantaneously created 18 file shares. So that's how we verify with the graphical user interface, but in case you're in Server Core, this is how we would verify with PowerShell. And so just a bit of information about, they're all using the resilient file system and their size. We can see the original disks were 250 gigabyte, and then our added disks were 350 gigabyte. And then the next goal of the lab will be to reset all of these disks and then combine them into a storage pool. And this is a technology since Server 2012, so instead of having individual disks like this, we'll create one big mega disk, and then we can start creating virtual disks from that mega storage pool. And then in the next lab, we'll do storage spaces direct, which is the example of horizontal scaling. So to reset, we're just going to get all of the shares that don't have a $sign in them and remove them. And how we would check that is here in shared folders and shares. Now we can see all of the shares are gone. Oh, these are the drive, and then the $sign is the drives. So all of the shares are removed, and then we did not remove any of the shares that had $signs. Those are the administrative shares. So the next piece is we have to get rid of these pesky partitions. So we've formatted all of these, and so now we're going to get them back to how they were before we formatted them. So we use the get partition command and then pipe it to remove partition. And now we can see the disks are back to their unallocated state. And then we'll also want to run the clear disk command and set the disk to offline. And now we can see it's going through and offlining all of the disks. Got a few more. Excellent. And so now we'll run that same command, and we'll see that all of those disks are available to be added to a storage pool. So now we'll create a storage pool and call it Mega Pool 01. So as we do this, we'll take a look at the graphical user interface. But we'll be using PowerShell. So this lives in files, file services. And it took just a second to load there, so just a bit sluggish on 1 gigabyte of memory. But you can see how the file and storage services have now popped in here. And this is where you could use the graphical user interface to create your storage pool. And we'll do that after we do it with PowerShell. So we'll go ahead and create the storage pool. So now when we bounce back over to the graphical user interface, there is our storage pool, Mega Pool 01. So now if we look for those same disks to see if they're available to be in a storage pool, we can see they are not. And then this is how you would get information about the storage pool if you were just in Server Core. So we can see here's Mega Pool 01 and then the other primordial pool. So now we'll create a virtual disk. So if we were going to do that in the graphical user interface, we do it here, but we'll execute it with the PowerShell command. So now that we have the disk, we could begin to create volumes. So we can see that's the 2 terabyte disk. And then if we wanted to, we could begin creating the volumes. And we'll do that towards the end of this demonstration. But for now, we'll continue on using PowerShell. And we'll use that same initialize raw offline disks function, because logically the operating system will just see this virtual disk as a disk. So now we can see it's the E drive ReFs for the file system. And then here's our 2 terabyte drive. So instead of having a bunch of little drives, we've now created a pool where we can create larger drives. And you can see it has a 4 kilobyte cluster size. So the idea is if this is an ReFs file share and maybe it's much, much larger, then maybe you would want to have a different cluster size. But you can see right now it's set to 4. And we can control that with PowerShell, and we can also control that with the graphical user interface. So we'll go ahead and update it with PowerShell. Oh, that was something wrong. So now we'll update the E drive to have the 256 kilobyte allocation table. And we've changed the file system type to NTFS. And then now we can just treat it just like any other data source and create a file share. So now we've created this file share called megashare01. And so now if we go and visit the share location, we can see we have the file share megashare01, which will be a 2 terabyte file share made from a virtual disk from a storage pool. And then since it has the NTFS file system, we can see we get the security tab. So now that we've done everything with PowerShell, we'll reset the lab and then do it with the graphical user interface. So the first thing we'll do is, I'll just run this as one big command. We will destroy the share and destroy the partitions. And then we're going to grab each disk, clear it. And then remove the storage pool. And then we'll just want to check. So these are, so we've reset the lab back to where we began, and now we can do the entire process with the graphical user interface. Okay, just took a second to update there. So we'll go into tasks, new storage pool. So we'll call it Mega 02. We'll choose all of the disks. And here we could specify hot, spare, or manual. And we could have done the same with PowerShell. And then here is how you would do it with the graphical user interface at creation time. So what we're doing is creating the storage pool. So now we have this storage pool from all of the disks. And now we can create a virtual disk from the storage pool. We'll do Mega Disk 02. And we'll do Parity. So this is data and the parity information are striped across the physical disks. We'll just do single parity. And then thin provisioning, we'll want to do that in our lab environments. And we'll go ahead and give it almost the entire disk. Excellent. And now that we have our disk, we can begin formatting our volume. We'll give it the letter K. And here we could specify REFs. And this is where you could specify the allocation size. And you can see how it wants to have a larger allocation size when using REFs. So we'll do 64K, or it gives you the option. Whereas if we did NTFS, it gives you much smaller options. The idea is maybe if you're doing this, maybe you want to have this. Interestingly enough, with PowerShell, we have much more control, and we can set it essentially to whatever value we need. So for now, we'll do the 64. And now we have our disk. And then with the graphical user interface, we could create a folder, call it Share01, right-click, Properties, share the folder. For now, we'll just do everyone. Just give everybody full control. So now when we visit the server name, we'll see the file share is presented in File Explorer. And so here is the file share. So to wrap up the vertical scaling example, excuse me, we started with our server with just a couple disks, 4 additional disks plus the operating system disk. And then we scaled the server vertically. We took storage disks and we just started adding them to the hard drive. So that is, or excuse me, adding the hard drives to the computer, to the server. And that is referred to as the vertical scaling. And so what happens is the server, you can only add so many hard drives before no more can be added. You'll hit your limit. And so that is the disadvantage to trying to have one big powerful server to do all of your file sharing. So if we operate in a cluster, as we run out of space, we can add more servers that can then have more disks attached to them. And then our limit becomes how many servers can we attach to the cluster. And that is referred to as the horizontal scaling. So this was the example of the vertical scaling. And so now we'll move on to doing storage spaces direct on a Windows failover cluster to demonstrate the horizontal scaling. To begin the horizontal scaling lab, I've done a bit of pre-work. So one of the requirements I feel for this lab is to have a router that is a Hyper-V server. And you might be able to use it with your home network, but this just gives you more control over the networking. And so I have an entire video series about how to configure this, and all of the code is available on my GitHub site. And then we'll just jump in here real quick and just take a look at what's going on. So in Windows Server, there is a role that we can activate that allows the server to act as a router. And so what I've done is set up an interface pointing to the internet, and then other interfaces pointing to local area networks. And we'll be using the AnkNet. And these other nets are for different video demonstrations that I have where we need more local area networks. For this failover cluster, we just need one domain So we just really need the one local area network. And then something to point out about this particular configuration is not only is it a router, it's also a DHCP server. So as we stand up different Hyper-V machines to be added to the cluster, once they are put on the local area network, they are given the IP address information via DHCP. And so then I have hard programmed in the DNS address of 192.168.77.7, and we will statically program that address assignment to the domain controller. That way, when we stand up these virtual machines, they get all their networking information, including DNS, so we can quickly add them to the domain. And so that's kind of a prerequisite for this lab. And if you need help, I have a different YouTube video that walks you through the process along with the helper code available on my GitHub repository. So it's just handling your networking. And then I have these two virtual machines that have been stood up, and they have some roles installed on them, and their computer names have been renamed. So on the Active Directory domain controller, it has the AD domain services role installed, and then I've just renamed the domain controller to Yahoo-DC01. So we'll begin by statically programming in the IP address. So we've set the IP address, and we've already installed the role, but now we need to promote the server to be a domain controller. And for this example, we'll be using minecraftmoose.com for the domain. And then I am going to pause the recording here just to time compress the video a bit while the domain is being stood up. Okay, excellent. The server is rebooting, and then after it reboots, it will be our domain controller. This part does take a second. When I've noticed when using 1 GB of memory, so we'll just give it a moment here. This part right here can take just a second. One thing we will need to be careful of is we'll be using the default administrator account here, and where it says sign into, we just want to make sure that is our domain name. Sometimes that will switch to the computer name, and then you will be logged in as the local administrator, but not the domain administrator. And when we go to use commands like invoke command, they will fail because you're just the local administrator, not the domain administrator. And the command would work if you use the credential parameter, and then you enter the credentials each time. But for us, we'll make sure that we're logged in as the domain administrators. So my custom image has 2 accounts that are created every time that the virtual machines are created. And when that happens on a domain controller, the users are added to the domain. So here on the domain controller, we'll run the get AD user and then dash filter, and then you do an asterisk, and this will show all of the users. And typically you would just have your administrator, but since my golden image had these accounts, the users are added to the domain. And they don't have any permissions. Even the administrator one is not like an enterprise admin. So this bit of code will place these two users into the enterprise admins and domain admins group. And so all that we're doing here is just showing that we've stood up this domain where we've got users. It's just like every other domain example that you may have seen. And so I actually have an entire video series about how to stand up domains, make domain trusts, and how to leverage different technologies to get into Azure. And that's what we're doing here, is just standing up a Active Directory domain services domain. And that is a prerequisite to having the Windows failover cluster. So I have stood up this Yahoo-PA. PA is Privileged Access Workstation. It will represent the machine where we do the configuration from. So I've gone in and installed these roles to shorten the length of the video. And the only roles that are installed on the PA are the management interfaces. So it won't participate in the cluster. It won't do anything but just be our user interface for the configuration. So we have the tools for clustering management, the Active Directory tools, DNS, and then group policy management. And then I've gone in and renamed the computer as well. So now we're going to add the computer to the minecraftmoose.com domain. Oh, and I'm going to go ahead and rename the computer. Forgot to execute that bit of line of code there. And then this just shows some of the tools that have been installed. And so we can see we've got failover clustering, the ADDS, and group policy management. So these are the big ones up here. And then PowerShell. And we also see the different modules. So here we've just set this firewall rule that allows the computer to respond to ping. Now we're going to add the computer to the domain. And the reason we're doing this is so that later in the lab we can use the invoke command and then list the servers that we want to configure without having to provide credentials each time or different credentials for each server. If they were standalone servers not part of a domain, they would each have their own username and password sets. When they are part of the same domain, we can use an enterprise or domain admin account to configure the computers, meaning that we don't have to enter our credentials each time. And in this particular example, I've gone in and loaded the PowerShell modules to configure the cluster as well. So this was the example that I was talking about. So we have typed in administrator. And if you have a keen eye, you'll notice where it says sign into changed to the name of the server. So if we were to log in right now, we would be logged in as the local administrator on the server, not a domain administrator. So when we would run that invoke command, it would fail. WinRM would not be happy because you would not be providing a valid credential set. You could provide the credential set and continue to be the local user, but if you log in as the domain administrator, launch your PowerShell as an administrator, then you won't have to enter your credentials each time. And so this won't happen with any other account really, but the default administrator account. So in production, it would be disabled, and so it's not an issue. But in these lab environments, if you're not paying attention, you might not realize you're not logged in as a domain account. You're just logged in as a local computer account. So to get around this, you just type in the name of the domain with a backslash. So now we are on the privileged access workstation, and it's freshly been joined to the domain, and we're logged in as the domain administrator. I'm going to open up a PowerShell window as an administrator. And so one way we can check, we can see the name is administrator.minecraftmoose. We can also do who am I, and this will indicate that we are the administrator in the minecraftmoose.com domain. So we can see minecraftmoose \administrator. And then to further drive the point home, since this is just a member server in groups, there's the administrators group. And if we didn't explicitly say we want to be the domain admin, we would have been logged in as him, which is a local computer account. Or you can see domain admins is a group. So we're not using the local computer account, we're using the domain account. So I do have another video series explaining this set of functions. So these functions allow me to quickly create virtual machines. And then I also have another video about how to make golden images so that we can quickly stand up virtual machines without having to go through so many setup steps. And all of that is available on my GitHub site, and the links are in the description. So what the function allows me to do, it's called new-lab_VM. We'll create these virtual machines that will be in our failover cluster. And it allows me to create non-OS disks and specify how many I want. So on each server, we're going to have 5 disks that are not an operating disk. So we'll have six disks total, but only 5 will be will be reserved for other purposes than the operating system. And then we can designate the size. And for the example, it'll be 200 gigabytes. And they'll be using Windows Server Core 2025. And then after we stand up and configure everything, we'll add in a 4th server to demonstrate horizontal scaling. can run these back to back. Make sure I have enough memory. And so we can observe the virtual machines as they're being created. So we can see the operating system disk. And then these are the 5 additional disks that are attached to the virtual machines. So we can see as they're being stood up, they are having the disks being attached to them. So you can do all of that with a graphical user interface. It takes just a little bit more time, but it's a lot more fun and a bit faster to script it and then add the disks at creation. And then I do have other functions that will help you add disks later, like we did in the vertical scaling lab. Oh, we got to initiate the third. So as the third cluster server is coming online, I'll jump into the first one and begin configuring. All we'll need to do is just rename the computers and set this firewall rule that allows them to respond to ping. Sometimes you have to refresh the window to get the enhanced session. Sometimes it will crash, and then just closing it, reopening it, keeps that enhanced session working. And like I mentioned before, since we're using DHCP, it has all of the networking information programmed in, and now we can add it to the domain. And now we'll just repeat the process on the second disk or server. And so since I'm using a golden image, the setup process is much quicker. So I used sysprep to create the golden image and then copy the .vhdx file as I create these servers. So it allows me to quickly stand up brand new servers as I need them. So we'll just rename the computer name, set that firewall rule, and then we'll join to the domain. And then we'll continue on to the third. And so one thing to note, as you have these servers, the Hyper-V Manager windows, they do take up memory. So by doing it this way with a privileged access workstation, we won't have to have so many windows open. We can just manage it from a single pane of glass. That's kind of the idea. So we're just going to set that firewall rule and rename the computer. All right, excellent. So we have joined all of our machines to the domain. So now we'll bounce over to our privileged access workstation, and we'll just take a look at our Active Directory environment. And it's very similar to the other lab that we've done. So you can see we've got some users in here. Here's Mega Man. Here's Rush. Here's the administrator. Here's our domain controller. And then our 4 domain joined member servers. So these will participate in the failover cluster. And this is just a member server with the management tools to do the configuration. And then we'll also just look at policy DNS. So here's the Minecraft Moose domain. This is all stuff that is in the curriculum. Here's the default domain policy that is now applied to all of the member servers. And then here's the domain controller policy that's just applied to the domain controller. And we could start creating and applying them. And then here we'll take a look at DNS. And we can see the DNS records are being created. So you get a lot of advantages with standing up your Active Directory domain services environment. So now that we have this environment up, we're going to leverage this technology known as failover clustering. And then within that configuration, we will use storage spaces direct. And then at the very end, we'll enable the scale out file server role onto the cluster and do a demonstration of horizontal scaling. So now we'll use this opportunity to demonstrate PowerShell Direct, which is a concept from the curriculum. So we will manage everything from the privileged access workstation. But to demonstrate how PowerShell Direct works, we'll come back here to our Hyper-V host, which has the Hyper-V PowerShell module installed on it. And what that does is give certain commands this parameter VM name. And this allows us to run PowerShell commands and reference them by their virtual machine name in Hyper-V. So the reason it's important to have the machine's domain joined is we can use the same username and password to authenticate to each. If we just stood these up and then wanted to do this, we would have to enter a different username and password set to authenticate to each one. So what I'm doing here is defining this variable called cred using the get credential command. And this allows me to create a PowerShell object that can have my password programmed into it. And we'll be using the MegaMan account that we made an enterprise and a domain admin, so they will have the credentials to run. So we'll be running it under as a different account than the one that we're logged in as. So this will prove that we can use this command with a valid credential set, and it will authenticate against all 3 servers. And then all we want to do is just get the computer name. So now we use WinRM to communicate with each one, and we can see we get the output of the usernames. So that was a demonstration of PowerShell Direct from the Hyper-V host. But for the rest of the demonstration, we'll be here on our privileged access workstation, which is domain joined, so we can use the same behavior, but with just the standard command set. And then this privileged access workstation has other PowerShell modules that we'll leverage to do the configurations. And then it also has the graphical user interfaces that we took a look at. So now instead of going to each one, we can use the invoke command to run the install Windows feature command on each one. And then we want to install the failover clustering rule. And so now the privileged access workstation will communicate with the servers over WinRM and begin installing the roles and features. And this does take just a bit of time, so I'm going to pause the recording to time compress the video just a bit. Okay, excellent. So we can see we're starting to get some success messages. And now we can see that the roles have been installed. And then next we're going to just reboot them. So we're going to leverage that same command, but just to run restart computer. And then we'll watch them reboot here in Server Manager. So that's another demonstration of the power of WinRM, is that we can just execute one line of code that can be run against multiple machines. And then we'll just check and make sure that the roles are installed. So we can see on each one has the failover clustering role. Just want to make sure. Okay, and then he finally rebooted. He took a second. So these two rebooted faster, and then he took just a bit longer. And that's why it's good to reboot the computer before doing the failover cluster. And then we're also going to use the test cluster PowerShell commandlet just to prove that we can make these servers be a cluster. It can be a bit tricky to make them all part of the same cluster if the servers are too different. We also don't have to use the invoke command because the PowerShell module is available on this domain join computer and we're logged in as the domain administrator. So we could have used the invoke command and run it on one of the cluster nodes, but we can actually just run it from the privileged access workstation. When we actually create the cluster, we can run it from this terminal as well. And so this output is a bit interesting. It's just worth noting some of the process. So here the environmental variables look good. It's checking software updates. It will move on to check networking requirements, storage requirements, and we'll see a bunch of really good output about the cluster. Here's some information about TPM, the Trusted Total Platform. Does it have a valid Active Directory configuration? So if we hadn't domain joined the computers, it would have failed there, and then the command would just stop. But this helps you, before you run the actual create command, this will help you identify issues with the cluster before actually creating it. And you can do this with the graphical user interface, and we're just doing it with PowerShell. So one of the roles that was installed was the failover cluster manager. So this server will not participate in the cluster, but it has the management tools. And right now you can see there's nothing going on. So we don't have any clusters. So here it went on to check the system configuration, the network configuration, storage spaces direct. So list all disk for storage spaces direct. It says the test passed. So we've got some disks that it would use for storage spaces direct, it looks like. And then we get this nice validation report at the end. And it's in the HTML format, so it will open up in the web browser. So we're ready to initiate the new -cluster command. And one of the things we have to specify is an IP address that the cluster will use. And so the network that we're on is 192.168.77.0/24. And we're just giving it an address within that range. And then we'll also get some great output here about the process. One of the interesting things that we will notice in the Active Directory environment is we now have a computer object with the name S2D cluster 01. So we'll just verify the git cluster command real quick, and then we'll use the invoke command to run the git AD computer on the domain controller. And so we can see there is this computer with the name S2D cluster 01. And then we'll also take a look in the GUI. And now we have this computer object in Active Directory. So that's pretty neat. So now that we have the cluster, we're going to enable storage spaces direct. And one thing to note is I'm running it on Yahoo Cluster 01, but you can actually run this on any of the servers in the cluster, and then it will enable it on all of the servers in the cluster. You just have to do it. You don't have to do it on each server. You just have to do it on one. Excellent. So now we've enabled the storage spaces direct on each server. And then we'll just check real quick with the git cluster S2D command, and we'll run it against each server, and we can see on each server it has the storage spaces direct installed. So one thing to note that happens now that the servers are in a cluster, there is now this folder called cluster storage. So now we'll take a look at it in File Explorer. So we can use $$ to reference the C drive. And then we can see this cluster storage folder. So how this is working is we will create just an example text file. And you'll see we actually don't have the permission yet. So we'll come back to this, but that is now part of the cluster. So we just want to make note of that we've got this new folder location. So we're going to see how many disks we have that are available to be in the cluster. Ran that from the host. So these are the 200 gigabyte disks that are attached to the 3 servers. So there should be 15 of them. 15. So now we're going to create a storage pool from those disks. So this is just like in the vertical scaling lab. We're using all of the disks to create a storage pool. So this next part is different. So now we're going to create clustered shared volumes. And this is a bit of a tricky concept. But now that we have this storage pool that has disks from 3 different servers, so we've taken all of these disks from these different servers, we've made the servers part of a cluster, and now we've taken all of their disks and made them into a storage pool. So in the vertical scaling example, it was just one server had a bunch of disks and we made the pool. Now we have multiple servers using their disks to make the storage pool. And now that we have that storage pool and it's in a cluster, we're going to create these cluster shared volumes. So that all looks excellent. All right. And so now we'll check using the git cluster shared volume. And we can see we have the different computer names and the owner. Now when we look inside the cluster storage folder, so earlier we tried to create a file in here and we're not allowed, but we used PowerShell to create these cluster shared volumes. And then now we can go in here and then use them like any other NTFS share. So you can see here's the security stuff. And so what's interesting about these, so if I create a folder, or we'll create a file here. So this file path right now is on the Yahoo Clus01, and it's referencing a folder from its C drive. Okay, so now we'll change it to 2, and the same file is here. So the concept is if we were to shut down one of the servers, that file would still be available. So we'll do more intrusive testing like that later, but this is just demonstrating how the clustered shared volumes work. And so on all 3 servers, they have that same cluster shared volume. So we just created the file on one, and it was replicated to all of the other servers. So now we'll come over to the failover cluster manager, and we'll kind of observe what we have set up so far. So we're going to connect to a cluster. So now we have connected to the cluster. So one thing to note is it doesn't have very many roles yet. So some roles you could install are Hyper-V and the scale out file server role. And that's what we'll be doing in this example is the scale out file server. So right now we can see the nodes in the cluster. We have 3 nodes. And then when we add the 4th, that will be the demonstration of the virtual scaling. Where this gets a bit confusing is we do have all of this storage going on, but we don't really see much other than the cluster pool that we've made. And then we can also see the cluster shared volumes. So under the disks, we can see all of the locations. So now we're going to enable the scale out file server role. And what's interesting about this is it's going to create an Active Directory object. So we'll go ahead and run this command. And it's the new storage file server is the command. Okay, excellent. So now when we go over to the graphical user interface, we can see we now have the scale out file server role. And then we also see the computer object in Active Directory. And then we'll just take a look at the graphical. Hit refresh. And here is the two computer objects, one representing the cluster, and then another representing the role. It's pretty neat. So this next block, what we're doing here is we're just creating a folder in each cluster shared volume. And then we're going to create a file share off of those folders. And then we'll grant access to the SMB shares, and then maybe fix some underlying ACL issues by running the set SMB path ACL command. So we'll go ahead and run this big block of code. And again, we're doing all of this from our privileged access workstation. So now when we go into these cluster shared volumes, we'll see the folders, and then we could start storing stuff in them. And so now when we access the computer object name for the role, we get the file shares. So that's what's super interesting about this, is now that we have this computer object, that's how we're accessing it with the scale out file server role. So now all of the file shares are available. And then what happens is we can begin shutting them down, starting them, and begin testing the high availability. So now we'll stop one of the machines. So when we look in Hyper-V Manager, we'll see that the machine is off. But looking at our cluster, everything is still operating. So we'll go ahead and add a file to one of these locations. So we'll put it on the first cluster shared volume. We'll create this file. Put our happy character. So this is back to our computer object, that is the scale out file server role. And then we'll go in, I think it was, and then here is our file with the happy character. So we've got a server down, but everything is still functioning. So go ahead and bring him back online. And then what we want to observe is going directly to the machine that was out of service. Might take a second for it to boot up. We'll see if it's... And so now it's back online, and when we go into that location, oops, here is our file. So the server went down, everything continued to work, server came back up, came right back online, and is now retaining the data. So that is an example of high availability. So we're now ready to add a node to the cluster to demonstrate horizontal scaling. So I'll need to get my functions back real quick. And then we will create the fourth cluster machine. This one will have 5 disks, 700 gigabytes each. So here is the fourth cluster machine. It's just coming online. I'm running just a bit thin on the memory, so that so now the machine should be booting up. So I found during my tests that I get about half of the host memory. So we're sitting at 1, 2, 3, 4, 5, 6, 7. So we're getting kind of full. Oops. And then we'll quickly set this firewall rule that allows the server to respond to ping. And then we will rename the computer. And all we need to do then is add the computer to the domain. And then we'll install the roles after we add the computer to the domain. And then we'll continue to manage everything from our privileged access workstation now that the fourth cluster is part of the domain. So we'll go ahead and install the failover clustering role onto the new newly domain joined member server. Okay, excellent. So the role has been installed, and now we'll just reboot the computer. And then we'll watch it go down and up in Hyper-V Manager. As you can see, it just went down. Now it's coming back online. And so this is great. Now we can run the test cluster and then just make sure that this fourth machine can participate in the cluster. So we'll just kind of watch the output here. And this is one of the key tests that we're looking at for this demonstration, is that all disk for storage space is direct. The tests have passed. So now we're ready to use the add cluster node to add the node to the S2D cluster 01. Cluster. So we'll go back into the graphical user interface for Failover Cluster Manager. And then we can see we have our fourth cluster is in the joining status. Excellent. So we come back here, we can see that we now have added the fourth server to the cluster, and we have demonstrated horizontal scaling. One of the things I found in the curriculum is it wants us to redistribute storage pool slabs so that performance and capacity are evenly utilized after adding the node. So what we'll do is, from our privileged access workstation, we will get all of the disks and then get the storage pool, make sure those disks are added, and then optimize the storage pool. So we will go ahead and add the disks and then optimize the storage pool. So we joined the server to the cluster, and then now we are working to add the physical disks to the storage pool. And then after the disks are added, we will then optimize the storage pool. You could run that from any of the servers, but we'll just go ahead and run it on the Yahoo Cluster 4. And now it has been optimized. And so that does conclude the horizontal scaling and failover clustering lab. And now we'll jump in to doing Azure File Sync, where we'll sync our on-premise file shares to an Azure file share. Now we'll move on to talking about implementing a hybrid file server infrastructure. So in Azure, this means connecting our Azure file share to a storage sync service, and that storage sync service is also connected to our Active Directory domain file shares. So this configuration will begin in the cloud, but I've carried on from our previous example and kept our domain controller, and then I've added 3 new servers to the domain. So Yahoo-File Sync 1, 2, and 3. So when we come in here to our privileged access workstation, we can see that we have these new servers in the domain. So we'll begin the configuration at portal.azure.com. So here we are on my Azure tenant. It's my lab environment, so there's not a whole lot going on. These are my resource groups, and as you can see, all I have is the Network Watcher resource group. So you can use the graphical user interface, but we'll be using the Cloud Shell to do all of the configurations. So the first thing we need to do is just define some variables. So resource group name, the AZ file sync resource group, its location, what we want the storage account name to be, the resource group name, the share name, sync group, and cloud endpoint name. So we'll go ahead and define all of these variables. Oh, it's connected to my mouse. There we go. So all we did was just define a bunch of string variables. So now we'll create a resource group and then a storage account within that resource group. So we'll monitor this on the graphical user interface in the portal. So there's our new resource group. And now we have a storage account inside of our resource group. So we'll define this variable for the storage account ID, and then we'll use some of these commands to observe the infrastructure. So there we're just defining a parameter, and then we are checking out the SP list on the Microsoft Storage Sync service. So this is needed for Azure File Sync. So we're just kind of confirming the properties look okay. So now we need to assign a role to that Microsoft.storage sync service. We need to give it the reader and data access role. So I was unhappy we didn't assign the principal type, but it's gone ahead and executed the command. And so now if we want to list the role assignment of the storage account, we can see the reader and data access role. So now we will use the Azure CLI or the AZ command to create and configure the file share. So we'll execute the command to create it, and then we'll use the show command to look at these settings. So we can see we now have a file share that has a quota of 500. So now what we'll do is go into the graphical user interface, come down here to data storage and classic file shares. And now we can see the Yahoo AZ file share 01. And so that was this parameter, which was share name. And when we scroll back up, we can see this is what we defined the share name to be. So we could have done that with the graphical user interface, but we're using the Cloud Shell. Now, as an example, we'll update the quota to 1000, and we'll also change the access tier. So we'll go back one. And so here we can see it is transaction. And so here we can see right now it's transaction optimized and the quota is 500 gigabytes. And so now we will update it. So the access tier is hot and the quota is 1000. And again, we could do that here in the graphical user interface, but we're using the Cloud Shell. So I hit refresh. Access tier is now hot and 1000 gigabytes. So that's just kind of how we can alter the settings of the Azure File Share. So we do need an extension. It's called Storage Sync. It's probably not in your Cloud Shell by default, so we'll need to enable this extension. So these were the extensions I had. You can see it was not an extension. And then I've come in and added the extension And now I have the storage sync command available to me. So that part is a bit tricky. So now we can actually create the storage sync service. So we define the service name up in the initial object definitions for all of our string objects. And now we're going to use it here. So now we need to go take a look at the storage sync service, and it's another object in our resource group. So this is where it starts to get a bit confusing. So the file share lives in the storage account, but all of the sync groups and the sync service is a completely different object. And so all we've done is just create it. So now we're going to create a sync group inside of that Azure File Sync Service object. So if we go into the storage sync service, we'll take a look at the current sync groups, and there won't be any. So we see sync groups, there'll be nothing here, and then we also won't have any registered servers yet. Sometimes you have to click around to get it to refresh. So here you can see we don't have any registered servers. Later we'll download the Azure File Sync agent, but we'll do it all with PowerShell and Azure Arc enabled servers. And we can see there are no sync groups. So right now we've got no registered servers and no sync groups. So this next command will create our first sync group inside of the sync service. And so again, we could have used the graphical user interface, but we're just using the Cloud Shell, and now we have our first sync group. So what will happen here is we would add our first cloud endpoint. We would find it in our subscription, use our storage account, and then here's our file share. But we're going to use PowerShell. And then we'll also get our server endpoints added. So we'll be using the storage account. There's the share name, and then the cloud endpoint name. This is the Azure File Share name. Now we can see the file share has actually been added as the cloud endpoint. So that, and then there's our confirmation output. So we officially have our file share connected, provisioned inside of our sync group, and you see it's grayed out. So the idea is you can only have one file share per sync group. So I'm leveraging the privileged access workstation that we've already created. And then I've gone in and created these virtual machines and then added them to the domain. So that's what this bit of code is. And then just for a test, we'll go ahead and configure this firewall rule on all of the servers from the privileged access workstation here. So we're just enabling that that firewall rule on each server, just to show that they are indeed domain joined. And then also to enable that the servers can respond to ping. And so now each of the servers has some raw offline disks. So we are going to start formatting all of these disks. So we will get the disk, and then we will get the partition style, define this disk's object. So we'll go ahead and do that right now. And then we get information about how the partition style is still raw and they are in the offline status. So this just gives us some information before we begin initializing them, formatting them, and configuring the file systems. So we'll do that right here with this bit of code. It's actually that same initialize disks function, but I've just stripped out the function and just put it inside the script block of the invoke command. So now this will go to each server and configure the disks. And then once the disks are created, we will create the file shares, and then those file shares will be used in our storage or our Azure File Sync setup. So go ahead and execute this. We'll just execute the formatting. Or excuse me, the configuring of the file shares. So now if we try to access one of the servers, we can see we have our file shares. And then each one has its own file shares. So now we'll begin onboarding the servers into Azure Arc. So we have our 3 on-premise servers, and we're going to onboard them into Azure Arc. So we need to make sure that the privileged access workstation has these PowerShell modules. And then we're going to leverage the PS session command to get all of them connected up into Azure. So this may take just a moment. And now that we have the modules, we will connect to Azure. And so we're presented with a device authentication code that we will plug in at this URL. So we will navigate to here. So now we'll plug in our administrator account in Azure. Excellent. And so now we've officially authenticated into Azure. And we get this nice output in the command line window about the MegaMan tenant. Now that we've connected the machine to the tenant, we can start onboarding our servers, our domain join servers, to Azure Arc. So we'll define these string variables and a session variable. So we're going to define this variable called sessions using the new ps session command, and then specifying our 3 servers, and then we'll use the invoke command but with the sessions parameter. So this was one of the commands that was highlighted in the curriculum, so I thought it would be a good spot to highlight how to use the invoke command with the session parameter. So we'll go ahead and initiate this. And all we were doing was getting the host name and what operating system is installed. So we can see the 2025 data center and then the computer names. And so now we will create the system assigned managed identity for the Arc object in Azure. And so we're using our Azure File Sync resource group and then the sessions parameter, or excuse me, object with the PS session parameter of this PowerShell command to then onboard all of the Azure servers at once. So it's a bit of a mouthful to explain. So up here we just demonstrated with the invoke command using the session parameter. And then we use the same object, but with a different command called connect-az connected machine. And now this is running on each of the servers and onboarding them to Azure Arc. So we'll switch gears and we'll go into our resource group. And then we'll start to see objects appear in this resource group that are Azure Arc instances of our servers. Excellent. So now we can see we have our 3 objects in our resource group that are Azure Arc servers. So that's pretty neat. So that's a big concept in the curriculum, is how do we extend the features of Azure to on-premise machines, and one solution is by onboarding it to Azure Arc. And then now we can apply RBAC to this object in Azure Arc. That's kind of the idea. So we'll just kind of look at some of the settings here. It will be just a bit sluggish. So I'll just kind of click around while it's loading. But we could apply an Azure policy to this object. We could run commands. And do role assignments. So Azure File Sync, what we're setting up, it used to leverage an Azure Key Vault. Now they want us to onboard our servers as Azure Arc objects. So that was a bit of the prerequisite before we run the storage sync agent .msi file. So now we need to run this on each server. So we'll leverage that invoke command one more time. And then it will run this if logic to determine the operating systems and then download the proper MSI file and then begin the install. And we'll let this wrap up here. So I believe we're okay since we saw the objects. This may be some kind of bug. So we'll just kind of leave this here and we'll open up a new tab and continue on with the configuration. So we'll go ahead and get the install file on each machine. And then this does take just a moment, so I will pause the recording while this executes. So after the command executed, it started the process for the storage sync agent. So now that .msi file has been run on each server. And then this output eventually caught up. I think it was just the output was still stacking up in the command line, and we just saw the objects in Azure a little bit faster. So the first thing we'll want to check is to make sure that the service is running on each server. So this is the storage sync service that we just installed with the .msi file. And we can see that the storage sync service is running on each of our domain join servers that are also objects in Azure Arc. So they're Arc enabled servers as well. So now we need to connect each device into Azure. We need to register the servers with the storage sync server. So we will initiate this command on all of these servers. And then we get our codes here. So we'll go ahead and start entering them. Excellent, and now we'll do the second one. And then our last one. And so we got some output that the Yahoo File Sync 2 was added, and we should get more output. Here, Yahoo File Sync 1, and then eventually we'll get here Sync 3. And excellent, it is done executing. So we'll return to the Azure portal. Go inside our resource group. Into the file sync service. And then we'll observe that we have registered these servers. Now that these servers have been registered, we can associate them to a sync group. So since they're registered at this point, we could finish off the configuration with the GUI by adding them in here, setting up cloud tiering, stuff like that, but we'll continue on to do the configuration with the Cloud Shell. Since I closed my Cloud Shell, I just want to make sure that I have my extension. Before running the command. So the extension was already installed, and here is a list of the servers. So now we will take that list and turn it into an object, and then we'll use the AZ storage sync group server endpoint create command to create the different endpoints. And so now each server will serve up a file share that will be synced to the Azure File Share. So we'll go ahead and run this last bit of code, and then we'll get all three servers syncing to our Azure File Share. So this E01, we'll just quickly take a look at the servers. So this is referencing the drive. So if we go to Yahoo File Sync 1, we can see here are the file shares. But if we reference it by the drive, we can see the Share01 folder inside of the E drive. So that is what we are referencing in this command, is the actual folder from the drive location. And then when we look at each one, they each have a drive that's E with the same folder. And then so each server will then share up that share. And then we have cloud tiering on, and then some stuff about the volume free space at 85%, and then start tiering files older than 15 days. So it looks like we may have got our first server synced in. Nope, not quite yet. So we'll just let this run. Okay, excellent. Looks like one may have been added to the sync group. So let's check it out. Excellent. So we can see 1 and 2 have been added to the sync group. Excellent. And so now that the servers are registered to the sync service and associated with the sync group, we'll give them a bit of time to do the first sync, and then we'll watch the statuses start to change. And then at this point, we're done with the configuration, and we'll do some testing with the environment. So I did pause the recording to give us just a bit of time to let all of this sync. So I'll go ahead and hit refresh. And we can see we have our first node that is online and healthy. So I'm going to pause the recording, and we'll just continue to wait until we see all of the nodes are healthy. So while we're waiting, we'll begin testing on the healthy node. So what we'll do, so we've got on file sync 1. So we'll come here on file sync 1 inside the share, and we'll create a text file called Yahoo. And inside we'll put our happy character. So now the goal is we have our on-premise file share that's sharing all of these files. And in this example, it's just one. And we want to get it synced up into Azure. So then we took the time to set up the Azure File Sync service. And so now we can have all of the files in the share synced up into Azure. So now we will bounce over to Azure. And we'll go directly to the file share in the storage account. So we'll come into the storage account, go into classic file shares, and then here's our file share. Then we're going to browse, and we can see there is our yahoo.txt file that we just created on the server. The service noticed there was a change, and then now it has been synced up into Azure. So we'll go ahead and download this, and here's our happy character. So that's excellent. So that demonstrates the technology. And now all we're really waiting on is just the other servers to finish getting synced to the sync group. So we'll come in here and check on their statuses. They still show provisioning. So let's go ahead and take a peek at 2. And we can see that the file has synced over to the other server. So that's pretty neat that these servers are syncing into Azure. So one server got this file with our happy character in it, synced it up to the Azure File Share. Now all the other servers that are participating in that Azure File Share also pull down the file. And then we'll just check out our third one. And we can see our happy character. So that's pretty neat. So we'll check on the status one more time here. Oh, excellent. And so now we've got 3 that has changed its status to healthy. So 3 was healthy, and so we'll go back to 2. Now see if we can So we'll do one more example while we're kind of waiting for everything to sync. So it's pretty neat. We've got all this set up. We might as well continue to do something with it. So now on the third server, we'll try a bit harder example, and we'll create a folder. And we'll do a bunch of the approximate. So now we'll go up into Azure, into the storage account, classic file shares, and then we'll check out our file share and browse. And now we can see the Yahoo folder 01 was created, and the text that will have all of the ASCII characters. So that's interesting that was the output. But that's because I used the approximation character, which is this wavy symbol. So what we'll do, we'll just update it to normal characters. So I think it has not updated yet. And now it's updated. So that's pretty neat. That's pretty neat how quickly the updates happen. And now we'll triple check on the other servers to make sure that we see the same result. So I'm just going to hit refresh. Looks like, oh, and they're here. So I didn't realize I was in the Yahoo folder. So we'll just go back to the eShare. And we'll go to 2. And we'll go to 1. Excellent, pretty neat. And then here is the file on each one. And so it did take just a bit of time, but now you can see that the servers are in a healthy state and they've uploaded to the cloud and even downloaded to the server. So this will conclude the AZ800 Storage Lab, where we talked about concepts like vertical scaling, horizontal scaling, storage spaces direct with a failover cluster, and volumes and partitions.